so in this video, we continue our tutorial discussion. We start with question number 10. So for question number 10a, they give you two graphs, which is x against t and v against t. They ask you to find the frequency of the object. Okay, one thing that you can find from the graph is that from the graph of v against t, the maximum value of v is actually 6. Okay, so you know that v max is actually equals to a omega. Okay, so this equation, it comes from v equals to plus minus omega square root of a squared minus x squared. Okay, so the maximum values when the maximum values of velocity is when x is equals to 0. You can imagine when it is at equilibrium. So when that happen, the equation over here, x becomes 0. You are left with omega a. Okay, and then you can substitute the values of 6 over here. The amplitude, you can refer to the graph of x against t, which is 2. So double check the unit, make sure it is in the same unit. So here they use the SI unit, so shouldn't be a problem. Omega here will be equals to 3 radian per second. Okay, so you know that omega is equals to 2 pi. Since the question want to find the frequency, right, so you use 2 pi f lah. F here equals to 3 divided by 2 pi. Okay, and if you press your calculator, you should get 0.48, and the unit would be hertz. Okay, the next question, question B, they ask you again, they give you two graphs, but here the graph that they give is actually x against t and a against t, so it's a little bit different. They ask you to determine the frequency of the motion from the graph in figure 9.3. Okay, so you can refer to the definition of simple harmonic motion, where x is equals to a omega squared. The equation would be a equals to x omega squared. Okay, I got confused a little bit. So the a is at the maximum when the position of the displacement is at amplitude, so it becomes a omega squared. This is when a max. Okay, again, you can refer to the graph of a against t, and then you straight away can deduce the values of a max, which is 10, the amplitude will be 4, and then you can calculate the omega. So here the omega will be 10 divided by 4, which is 2.5, but then you still have to take the square root. That would be 1.58 radian per second. Now once you get this one, you can straight away find the, so this one is for question B. Straight away you can find the frequency by using the same equation as before. So f is basically omega divided by 2 pi, which is 1.58 divided by 2 pi. Here you get 0.25 hertz. Okay, so I'm going to make this one a little bit smaller. Then over here. And then for question C, they give you a graph of f against x, okay, and then they ask you to find the period of oscillation and the maximum speed of the object. Okay, you know that f will be equals to ma, so it's from chapter 4, and acceleration from this chapter is actually equals to, if you refer back to this equation, x omega squared. If I choose the position at the maximum over here, let's see if I choose somewhere over here, then you can substitute the values of 4 for the force. Mass is given, which is 2 kilogram. Okay. Since this one is at the maximum, this one is basically A, right, at the amplitude. So I substitute the value straight away. And then omega squared is omega squared. You can find the omega. But here is 4.47 radian per second. Okay. Once you get this one, you can straight away find the period using 2 pi over t. And our t is equals to 2 pi divided by 4.47, which is 1.41. And this is a period, so it will be in second. You still have another question, which is C number 2, and they ask you to find the maximum speed of the object. You do have the amplitude and the omega, so if that one is 1, okay, question 2, you can use formula of V equals to plus minus omega square root of a squared minus x squared. Since we are talking about the maximum V, then x equals to 0, V max, when x is equals to 0, then you're left with V max equals to omega A, which is equals to 4.47 multiplied with the amplitude, which is 0.1. So basically divide by 10. Here we got V max equals to 0.45 meter per second. Oops. Okay, so that's it for question 10.